The times are changing, and so is the world around you. At CVM University, we help you prepare for the future, like we have with more than 10 lakh students. Come, join the educational legacy of 75 years. CVM University, enlightening the future generations.
Good morning, all. I, Ainesh Joshi, on behalf of ADIT and CVM family, welcomes you all. Now, I would invite Dr. Ajit James to begin with the session. Please, sir. Good morning, all. I, Ainesh Joshi, on behalf of ADIT.
Good morning to all of you.
Dr. Ajit James to begin with the session.
I'm Dr. Ajit Tom James. I cordially invite all of you for this webinar. Because of some technical difficulty, we were unable to start in the proper time. So without wasting the time, I now invite our principal, Dr. Vishal Singh, to say a few words, and immediately after that, we will start this session. Thank you.
A very good morning to all of you. I welcome Mr. Syed Mubashshir Ali, who has taken time from his busy schedule to spare his words of wisdom. The topic that he is going to talk upon, DFMA methodology, is one of the advanced area wherein design of manufacture and assembly is being discussed and elaborated upon. When combined with lean manufacturing, it further offers better operational capabilities. Mr. Syed is a mechanical engineer from MS Ramaiah Institute of Technology, Bangalore, and he has completed seed transformation from Stanford University, California. He is a cost analyst and a consultant with the D. Espat Private Limited, Chennai, and he works in the area of DFMA. Many students have joined across the India on our YouTube live session. I hope this would add value and wisdom to all those who would watch this particular session now and later. I welcome you, sir, and please begin with the session. Thank you.
Thank you, Dr. Vishal. Thank you, Ajit. I'll take the opportunity to start my presentation without much ado.
Sure.
I just quickly check if you can see my screen. Thank you so much, ladies and gentlemen. And I believe there's a big fraternity of a student community from universities. So I hope I can catch up and make up for the time that we have lost. First of all, a big thanks to all those who are behind the screens helping us to put this event today. So we're going to talk about this role of design for manufacturing assembly in new product design. And the insights I'd like to share in this next 1 hour is what do you think is the importance of validating design? It's a question that I'd like you to ponder as I show through my go through my presentation. What do you think would be important in identifying cost at every stage of your product design cycle, right from the concept through completion? So before I go ahead, I just like to have some house rules in the interest of all of us who are here today. Please have something like a pen and paper or a tab to make notes of what you see. Basically, if you have questions or clarifications, make sure that you can shoot it out in the chat box. What I want to also tell you is I don't have access to this till the moderators would allow me towards the end of the session. So if I'm not answering to your chat questions, you know why. And in case, just like this earlier part, if technology plays a problem and you're not able to continue seeing our session, do come back to the YouTube, of course, or this is my email in case you want to catch up with me or my colleagues to write to us or have further clarifications. So how I plan to present today's session is I want to talk about this methodology that has been available for the last 4 decades in the world. This methodology from our principals, Dr. Jeffrey Boothroyd and Dr. Peter Duest. They have a methodology called Design for Assembly, which allows user to do design review. Why would we want to do design review, and what aspect of design review? It is basically if you want to check the benefit of having time penalty and cost implications of your design intent. And if you have different what if scenarios to play out with your new ideas and iterations, this tool is the numero uno in giving you a world standard comparison feedback of your design intent. The other aspect of anybody who's developing a product would be how much does it cost to make the parts in my design. So this module called Design for Manufacture has a database of the last 35-40 years where industry best practices and time studies are accounted for, which allows you to very simultaneously or concurrently have a rapid feedback of your part cost information, difficulties of building your or manufacturing your part, while at the same time this module is very user friendly. Of course, the latest version is, which allows you to look at the part and say, hey, what if I make this part instead of say casting as a sheet metal component? Why sheet metal? What if I look at it as an injection molded component? You can do all of these iterations as a user. And can I tell you a secret? If you want to know a secret, please say yes, I want to know a secret, or yes in the chat box. I'm assuming that you're saying, and thank you for those who are saying that. You can do all of this without the need of referring to a manufacturing expert. How's that? Okay, so you can focus on your design. Well, there's a tool that can help you to validate your ideas and iterations. So in order to do that, I've taken an example of a assembly. It is called a position sensing motor assembly. This is a very complex part used in a large printer. This is the bill of materials of the part in that motor assembly, as you see. So in order to help you all to catch up with what this product would look like when it is assembled and how it would be assembled on the shop floor, I'm going to run you a quick 20-second video and explain or elaborate as I run you through it. I hope you all are okay with that. Okay, so look out for these details that I'm going to spell out on the video. Just give me a second while I sort of iterate and span it out on the screen. I hope that. Is that a message for some to me? I'm not sure I hear audio back to me. Can I continue, Anish? If yes, please say yes on the chat box, please. So I'll assume that it is good to go. And this is the overview of the bill of materials. And I'm going to run you through this video, pausing in between to explain the parts that get assembled. So this blue color base component is an aluminum base part. And it is going to get assembled first with a set of these cylindrical, hollow cylindrical parts made of brass called the bushings. This is then assembled with this pink color component, which is a motor, and it is supplied by our vendor. And it is held in position by means of 2 motor screws. What comes down now, and I would like your attention to this component called the standoff. This standoff mounts itself on the base. This red part is a sensor held in position by a sensor screw. What comes down now is an interesting part of our review today. We call the sheet metal part in green color called the end plate. That's going to be placed on the standoff. This is a plastic or a rubber grommet, which is an insulation component. You know, we have a motor and a sensor, so a bunch of wires will have to be insulated from the metal part. That is inserted there. The end plate is going to be held in position by means of 2 end plate screws. And what comes down as the last member is this green color component from the bottom sliding up called the cover, held in position by these cover screws. I hope that video was useful to understand the overall assembly. I'll keep this in a minimized position. We'll come back to it a little later. So that's what this beautiful bomb looks like when it has to be assembled. Okay. Now, I again would like to bring a focus on some parts which we're going to review for in today's session. I've got these parts that I've listed on the left-hand side, and I want to quickly tell you what do we know about these parts. So this is a component called the end plate and this component called the cover. Basically together, they form the enclosure of the product. Now, if you query, why do you want this enclosure? It's very simple. This is a motor working in a very harsh environment or in an environment, and you need protection from the environment. So these components provide that protection feature. Okay, and I like you to note this point that this is an enclosure that's going to provide the protection or safety aspect of the product. How are these parts held together? It explains the remaining 8-9 parts that are there. The rest of the parts serve to fasten these two major components into position. Okay. Now that said, let me bring a snapshot of my video I showed you a few minutes ago. This is what the two parts would look like when assembled. Please do have an image of this in your mind as we go ahead to analyze what we're going to do in terms of time and cost simplification. So when let us say we are given a task to review this design and say, hey, let us say we are part of a team and our management has said, you know what, can you find some ways to minimize the overall cost of this product? Okay. There are several things that one undertakes as a part of this review process. And that's my session, first part of my overview session today, which is talking about design review and particularly giving you a perspective of the design for assembly overview aligned to this thought process. So several different things one would do in order to get ahead. But I would like to ask these questions to the audience. When you come out with new ideas, how do you quantify that? How do you quantify the function of the parts? Let us say we are capable of doing this and we follow certain methods. The question next is, how quickly can you do it? Then how reliably can you do it? When I say reliably, what I'm bringing to notice is, when you come out with an idea, how do you convince your team members, your project members, your management, or your customer that this aspect that I've come out with is good, it is correct, it is better? These are many aspects that are of concern. So that said, I'd like to ask you, are you ready to discover a technique that is used by some of the Fortune 1000 companies in this realm of business? If yes, please say yes in the chat box. If you say yes, my moderators are going to give me a yes on the Google Meet too. Thank you. So let me take you to a quick intro of the first module. And this is the overview of the same product that I showed you earlier in an exploded view in our software module. So first of all, somebody gives me a bomb like this, I'm not sure how should be the assembly sequence. So that's something as a designer one should be aware of, or talk to the concerned operators or a assembler on the shop floor to figure out how this is assembled. So let me, are you able to see my screen which has a user interface of DFA? If yes, can you please give me a shout on the chat box, please? Thank you, Gandhi. So, gentlemen, this is the graphics user interface of design for assembly module. It is a 3-part window. On the left-hand side, you will prepare your bill of materials in the sequence that you foresee assembly on the shop floor. I can add a part, I can give it a name, or I can also import this part if I have a CAD model. I can import this part from, if your CAD model does automatic bill of materials creation, you can import a bill of materials as a text file. That is also possible. Let us talk about an angle where we are keying in the information. So when you talk about a part, the DFA method is such that it is a question and answers based review method. So what you see on the right hand side is called the question and answers panel. Okay, and as you keep entering answer or giving details in the question and answers panel, what you get at the bottom is a cost review and a time review of assembling your part. So when I start out an analysis with the DFA, a couple of things that you need to know is how many parts you'd like to make. Maybe it's one prototype, maybe tens of thousands or maybe hundreds of thousands. It depends on what kind of an environment you're working. Of course, if you're a university grad, you'll probably talk about doing one prototype. You may want to have an estimate of how much does it cost you to spend time on your operator. And this is basically oriented towards the industry. So these things are also relevant. Okay. And how much is your efficiency in terms of your work that you do? You may say, oh, how much of time am I spending on a project? If I'm spending, say, 50% of my time on my project, that number should probably go there. So coming to each component in your product, what the software wants to know is a very user-friendly, easy to answer questions. And it is a perspective of the user. So you'll say what type of a component your this idea is, whether it is a part or a sub-assembly. What is the weight profile of your product? What is the, not product, component, I'm sorry. What's the overall geometry of your part? Now, if you see, we have two envelope dimension opportunities to enter the overall size of your part. Now, I'll just pause for a moment and tell you. Now, you may say, sir, I have a very complicated and complex part. Why should I just give overall geometry? So the Boothroyd method is more concerned about what is the overall length, width, and height, or XYZ dimensions of the part while handling storage, transportation, and how the operator interacts with the part. So no matter how complex the part is, how a human or a equipment interacts with the part to bring it for assembly is our area of interest. So how do we answer that? There are 2-3 elements that are going forward. One is you will have to figure out and explain what is this item or your part doing. Is it a fastener? Who's a fastener? Nut, bolt, screw, rivet, washer, or fasteners? Connectors. Connectors are those elements which are like tubes, wires, conduits, cables, ropes. Or you must say, hey, I have an established value or a function for my part. If you click this item, then you have to say, under these 4 categories, what do you think is more relevant for your part? For example, when I say base, this is more relevant one to say that it is a base part. Okay, if those are parts that move or rotate, then you'll say this is the more relevant option. If it is a part or a component that has different material properties, for example, I have an electrical insulation or I have a thermal separator. This is a requisite requirement of the material property. Then only my product can function. If that is the case, then you'll select this opportunity. Or if it is a component that has to be allowed separate for assembly. What this means is, for example, let us say your cylinder head of the motorcycle engine or a car. The cylinder head and the cylinder are made of the same material. But in order to allow assembly of the components inside the cylinder, it is important that the cylinder head be as a separate component. That will be an opportunity to select this as a separate to allow assembly option. If it doesn't satisfy any of this, please be critical and select the next option saying, hey, I don't see any fundamental reason for this component to exist. If you're capable of doing this very unbiased manner, you will start finding opportunities to start saving. Okay. There are 2 more things that you'll probably need to add about the product as you assemble. This is your foresight about how you think the component is assembled. If it is a symmetric component, what kind of symmetry it has. Because more symmetric a part, I like you to notice when I click on 2 axes, what happens to the process time. It will change. Okay, it will become different depending upon the symmetry of the part. So more symmetric, lesser time, and lesser confusion, lesser mistakes to assemble the part. I'm sure you agree, right? And the next part that we want to sort of investigate about the part. See, I want you to understand that all of these attributes that you're talking about is on the shop floor, you've designed your part which has been manufactured and available for the operator to assemble. And when he's assembling, what are the issues he faces? How does he interact with the part to bring it and assemble into the full product? Those are the questions we are answering here. So it involves a physical activity. That's what these questions are. How does the operator handle the part? Does he have any difficulties? He or she have any difficulties? If yes, then you'll click it. You must know that each click means you're adding penalty time for assembly. Each selection of a different securing process means you get a penalty time aligned to the process. For example, if I had, let me go back to this original design, wherein in this review, I've added all of the questions related to the parts. I have also keyed in all of the parts in the bill of materials. So this guy on the left-hand side, this little window is called not the bill of materials, but we have a name uniquely for it called the product structure chart. So what is included in the product structure chart is bill of materials, but also operations, standard and non-standard operations that are required for a component or to be assembled to form the full product. This right-hand side is the question and answers panel. And for each entry that you make on the question, you get a review on the bottom left-hand corner. Now, in the interest of time, I have a product. This is my assembly, and I have keyed in all the components in this design of the parts that are here. Now, my area of interest, which is the focus of today, is to help you say do design review. And I'm basically looking at out these parts, that is the cover and the end plate, and the components that are going to assemble them together. So in our tool, when you do any design entry like this, once you have done this question and answers entry format of information collection, you can do a beautiful postmortem through industrial engineering worksheet generation. Okay. And I'm not going to get into this in the interest of time, but more importantly, a very fast and relevant feature called suggestions for redesign. Ladies and gentlemen, this is a very interesting review capability of the design for assembly module. What it does is it gives you a rapid breakdown of opportunities based on the entries that you have given as a user of where there are possibilities to save. So let me jump into this category 2, which you can see. Can you see this category 2 on the right hand side, gentlemen? I'll wait for a yes from Takshak so that I can go ahead. Yeah, thanks. So I'm going to click on this element called fasteners and see what happens. Okay. If you look at this review under fasteners, this product called motor assembly has 4 different types of fasteners. That's what this means. Let me go and bring your attention again closely to this element called the cover screw, which seems to be the largest time contributor for assembly. Excuse me. So if you dwell on this and see and look at the product process time for most of the components, coincidentally, this element called the cover screw has the largest time contribution, okay, in putting this part together. So if I quickly nudge back to my presentation and show you the slide, this is a cover screw. Now let us just talk about this for a minute. What is this cover doing? It is holding the cover in place. What is the cover doing? It is doing the action of protection. Is the cover alone the component that is doing protection? Let's do this review going forward. So I have done what I've done a quick extract from my DFA review and put it up in the slide for one view dashboard for all of us to quickly understand. I have marked this part count under 2 different headers. One, I call them protection components, the end plate, which is this fellow on the left-hand side, the L-shaped component, and the cover, the one on the bottom. These 2 together form the active covering or protection. And in order to get them together and be fastened or held in position, we have this end plate screw. Does the end plate screw fasten itself to the end plate? No, it goes through the standoff. And if you remember the video, the standoff is fastened to the base plate. And we have this cover, which is held in position by these 4 cover screws. So, ladies and gentlemen, what I've done is a neat extraction of data from what I saw as the time contributor for the cover screws. It takes 34 seconds. And when I did a reverse thinking of why the cover screws is there, because it's holding the cover in place. What is the cover there? It is doing protection. Is the cover alone doing the protection? No, I also have an additional component called end plate. This system of brainstorming and negotiating and deliberating with my team, I found out that I have in this product 10 components that serve this feature of doing a protection function. You agree with me? Do you see what I'm trying to tell you here? If yes, please say yes on the chat box. So what do we do once you find an opportunity to review, right? You need to form your team, you brainstorm with them. And you brainstorming alone is not sufficient. You want to do creation of your ideas or representation of ideas through sketches and 3D models, whatever is available with you. And of course, there is a lot of deliberations that go back and forth. You need a convincing approach. Well, that is the word. You need to convince somebody to say, buy in this design and let's go make this new proposal that we are going to make. And most likely, all of these opportunities is either value addition or value engineering, or most likely an opportunity to have a new design. Now, a new design, and if there are manufacturing friends here, and they will agree that's an expensive ordeal to take on, right? So, because there are some challenges that every engineer will probably have to go through in order to push his design idea. So there's some of the questions that I put here. If the design team has this creative or new proposal or new idea, what do you do about it? Let us say you have a proposal that is an entirely new design or a creative design. How will you quantify and convince yourself as well as your team that this is the way to go forward? I've just drawn a sketch of what this product alternate idea looks like. Of course, this doesn't happen so fast like we're doing in this demo today. It goes through many iterations, sleepovers, deliberations before it comes to the stage. But this is the long story told short. So this is what the cover looks like when it is assembled with these two parts. This is what it looks like when it is in this assembled stage. What if you make it like a component like this? This need not be necessarily a CAD model. This could just be a sketch like I've showed you on this piece of paper that I've drawn. But this is the way it goes forward when I see the functional aspect of these parts coming together. If you agree, or if you see some agreement, or if you see some confusion, please say something on the chat box. So now this brings us to the next additional set of things is, what do you do with this new idea? Let's say the idea seems fantastic. Who's going to find how much of time and resources to be allocated for this task? I now will talk about those who are from the industry fraternity, because industry has different challenges. Like you already have priority of projects. Then how do you take this up? When should you take it up? How meaningful or top priority is this product in your line of profits for the company, or outreach for selling to the customers in more volumes? So these are some challenges if you're looking from an industry perspective. But again, whether you're academician or whether you're industry, who do you reach out to get information to, or participants who will reach out to in order to get a more clarity on this design intent that you've created? So that brings us to the next aspect of my idea, which is called part costing. So again, what I'm going to do is I'm going to jump back to my tool and continue the story. Can I do that? So I'm starting where I left off. So where I left off was, I was looking at this design review part wherein I looked at fasteners, okay, and I looked at cover screw, the largest time contributor. I challenged what this cover screw is doing. I found out what it is doing. Then I came out with a new idea. Got it? Now, if I have such an idea, what I can do with the DFA tool, ladies and gentlemen, is I can prepare a quick intent of this existing idea and make a copy of that, and probably make a new proposal of my proposed new idea. Again, let me tell you, I'm not having CAD data at this point. This drawing that you see here is just a drawing or probably a sketch or just an overview dimensions. Even with this kind of stage of information available to me, I can do a very relevant comparison of my design intent. So what comes out when I have a new proposal that I can probably bring is I can create several different rapid feedback of my design intent. Let me just quickly help you read this report. So what was an original design of 36 parts? It could probably become a potential 8-part candidate. What took about 260 seconds of assembly time could now become a 72-part component. And also what I'm able to do with this TFA method approach is I can create a design efficiency measurement of what my existing design was and what is my proposed new design going to be. And this will be an area of excitement for us to see whether we can proceed with the design and so on. Now you may say, sir, you have done this demo and kept prepared. How do I know that I can really do something like this in the real world? So let me do a couple of real-time scenarios in the next 2-3 minutes, okay? Before I jump to the other aspect, which is called part costing using DFM. So let me blow this up for you. Look at this motor for a minute. If you remember, I told you that this motor is a vendor supplied part. Okay, let me open the more colorful exploded view in this 3D view. Can you see this, Anish Ji? You'll have to keep giving me feedback so that I know that I'm on the right track and it's visible. Super. Thank you so much for that. Now this motor, if you see, has a very regular size base, which is almost like a square. Actually, it is a square. Now, I'm just putting a hypothetical situation for you guys. Okay. Now, when my operator assembles a motor, he can put this motor, which has these diagonal 2 holes, either this way, or he can rotate it 180 degrees and put it inserted the other way. Very possible, isn't it? What happens because of that in the real world is probably, if the guy puts it in the wrong direction, the motor wires, it becomes a little shorter to come out of the total motor assembly. So I was thinking about this, let us say, and I'm going to tell my motor assembler, you know what? I learned from this guy called Syed about part count reduction. So here's what I want you to do for me. Since you're going to supply motors for our company XYZ, I want you to cut off this corner like a chamfer, like your SIM card, and have a chamfer here. I will ask my aluminum supplier to have a chamfer here. So I will make these 2 parts, no error, and I'll use only 1 screw to fasten. Let us say for a moment this is a good idea to do mistake proofing. You know what I can do? I can find out what is the benefit of that, or does it really make sense from a DFA perspective? Can I go and show you that? If you are interested, say yes on the chat box. Awesome. Thank you so much for that. So what I'm going to do is I'm going to make a copy of this. I'm going to paste this. I'll rename this and we'll call it ADIT idea 1. Okay. This idea 1, what I'm going to do is I had a motor which is supposed to be placed in position. And this motor screw, which had 2 numbers, which was fastened using a threaded operation. Of course, motor screws are threaded, right? And the beautiful thing about DFA is, depending on the process you select, it will bring up the operation characteristics that is required. If I selected added held down, it brings up different types of questions. If I select snap fit, it brings up a different snap fit question. If I say pop riveting, it will bring up the operation characteristics of pop riveting. If I said threaded operation, it brings up the operation characteristics for a threaded component. Again, database is so vast, ladies and gentlemen. If you type different types of methods for fastening, you will get different feedback about how much it costs in terms of time and to assemble it. Now, have you ever thought about it as a user when you build a functional component? Because most of the times as a designer, we are used to achieving a function of the product, right? For which we are designing these parts, right?
Yes, sir.
So
Yes, sir.
most of the time we are not challenging the parts as to how much of the time they are contributing to achieve and so on. But the beautiful thing about when you do a DFA approach, let us say if I have 4 revolutions to fasten with the nut screwdriver, the process time is 18. If I change that from 4 to 14, okay, I can get upfront what is going to be the time for fastening. So I can look at attributes like this and build much better, more simpler, less time consuming product builds. Okay. So anyway, in this case, what I want to come back to and say is I don't have a motor, and my motor is going to be having for fastening 4th revolution fasten. Sorry, I got a little distracted with somebody coming in. And I will say instead of 2 screws, I'll have 1 screw to fasten. I can get a rapid feedback of this in design intent under different result proposal right now. And I'll say, this was what we created just now. Okay, so there's a product profile breakup in terms of process time. Okay, and if you look at this, interestingly, gentlemen, the red color represents the original design. The DFA represents what I had as a sample. This DFA ADIT idea is what I just created for you in a minute. If you also look at it, interestingly, world over, you'll see this behavior. Fasteners contribute about 60 to 70% of assembly time. I hope you can see that little marker there. This is the original design. In the revised design, it becomes much smaller, and this is the proposed new design. Interesting?
Yes, sir.
What I'm going to do is, I have another idea around this motors group. Just like your pen caps, which snap fit into position, I got a creative new idea for this part. What I have as an idea, I'll just quickly show you on the exploded view. And I figured out I can save a lot of time if I remove this fastener. So crazy as that might sound to you, I'm saying, I'm going to tell my motor supplier, you know what, give me a snap fit ring around this motor base. I'm going to snap it into position on this base part, the aluminum. Right now it is aluminum. Maybe I will consider to make it of some other material in the future, because I want to find a cost opportunity to save there also. But the question is, what if this is a snap fit design? Okay. While the process usually we would engage is, let's go do the engineering, let's see whether there's interference check and so on and so forth. What I do is we advocate you go and prepare your proposed idea in this risk-free environment. Okay, I'm going to call this idea as Snap 2. Okay, in which I'm saying I don't want to have the motor screw anymore. I'll delete it. Instead, I will take the motor itself as a snap in position component. It's asking me how many snaps do you want. I'll leave it at 1. And ladies and gentlemen, in the last 3-4 minutes, I have created 2 ideas for you in the overall picture of things for doing a design review, and a tool that is capable of giving you a product profile breakup in several different attributes. Okay. And in not only can you see, now I'm showing you a different profile report in the interest of time. I'm showing you what is the cost breakup. So in the original design, this is how I want you to read this report. In the original design, the total cost for just assembling alone, not the cost of the components. I repeat, it is the cost of the assembly that the company is spending in assembling these components to form the complete product is $3.41, of which, if I move here on this fastener, the red color one, the first one, 2.08 is the cost only to put fasteners together. How bad is that? Okay. And if you look at this components, which the user has said is necessary components, in the red color, which is the original design, the cost of this is only 32 cents or 9% of the total cost. Can I tell you some a secret here, or something which is industry knows?
Please.
Anish, you're only saying please, or there's a crowd at the YouTube is also saying yes in the chat box.
They are also saying yes, sir.
Beautiful, sir. Very nice. Actually, I'm running blind, so it's nice to know that the participants are giving and you're reading it out for me. Thank you, Anish.
Yes.
So the secret thing is, ladies and gentlemen, many times a product breakup has a large portion of assembly cost and time around unnecessary and basically fastening elements. The actual functional parts of the product have a lesser time contributor from assembly perspective. If you already knew this, what I'm telling you is, here's a tool that allows you to do a much more intense review in a very user-friendly and a consistent manner. If you didn't know this, well, this is a tool that you should probably start deploying in your projects or products to start making design reviews. So let me quickly read this out before I go to the next session of our part, which is called the part costing. So what was a $3.40 component? It's a potential, it could probably become up to a 72 cents. Let's talk in rupees. 3 rupees 50 paisa, let us say, can become 70 paisa. Potential to save about 80% exists in the virtual world when you're doing this review consistently and brainstorming and finding out what is the outcome of your design intent. I hope this helps you to find to understand what kind of a role this tool can play in the reviewing of your ideas. And of course, the tool has several different types of reports generation. We'll talk about it in another opportunity. But let's go and move on to the next session of my presentation. Can I move on to the next session of my presentation?
Yes, sir. Please.
Now we have this part. Okay, I'm telling the story around the same product, which we have now sort of improved. And if you're seeing my screen, these are some challenges that any industry or a designer would have. Okay, this looks like a good idea. DFA says it's got good potential to save in terms of assembly time. But hey, what's a good process to make this part? If I change the process, what happens to the cost? Will I get savings? Will it become more? If I'm a part of a company, can I give this information very credibly to my purchasing or a procurement team so that they can influence the vendors in how they will procure these parts? What happens if I can work with, say, Vietnam or Malaysia or somebody to manufacture this? Consciously, I'm not using China because we are in a scenario where we want to get away from it. So, but these are things that companies keep considering, right? So the potential, right, we saw from a part costing perspective, I like to talk about it before I go there, is if you do have an opportunity to save from and simplify your product, what was that complex product could probably have a potential to become something simpler like this. Before I go, what I'm showing you here as options for cover, I've listed 3 options that I want to show to you as a candidate for making this part. I'm going to show you in about the next 10-15 minutes. Can we explore making this part an injection mold using plastic? Can I use, say, low carbon steel and make it as a sheet metal component? Can I use, say, aluminum and make it in die casting? Would you be interested to see that?
Yes, sir.
Awesome. So let me go back and open a DFM module. So this is the design for manufacture module that I have here. This is a 3-part window again. One on the left-hand side is called your process chart. On the right-hand side is data related to the process, and bottom is the cost per part that you would get. What I'm going to do is I'm going to minimize this, okay? And I'm going to show you the feature called concurrent costing by opening up the DFA, okay? So I've come to this DFA part where I have this idea of this cover. And I'm going to take this idea of this cover and I can concurrently open this component through my DFA analysis concurrent connector and say, create a new DFM analysis. Okay, I will say ADIT sample. And what happens is this cover information. Okay, just give it a second. This cover information, which has this overall geometry. Just have a quick look at this 114, 71, 58 is the dimensions of the part. This motor assembly, we want to make 5,000 pieces. All of this information can simultaneously come into your DFM window. Now, before I go ahead, I want to tell you this, that imagine if you have a design team working somewhere in one part of the globe, and you have a manufacturing expert or a manufacturing vendor sitting somewhere else, and these 2 guys or companies are connected to the same server, they can simultaneously exchange information like this. That's why our tool is called concurrent costing tool. So without much ado, what I'm showing you here is that the data from that cover in the DFA has come into my DFM module. Okay, it is just asking me for one information and saying, hey, please, can you give the thickness? So I'll say, okay, I want to have a thickness of about 2.5 mm for this part. I have selected an overall geometry. The life volume is automatically come in. And ladies and gentlemen, I'm going to show you something which is very, very interesting and very proprietary to our tool. You select this process and material icon. Okay, and what comes up, are you able to see this process material selection chart?
Sir. Yes, sir.
Okay, this is very unique to DFM, which means given let me make this a little smaller so you can see both parts of the window. Okay, if you're given a geometry, given a life volume, you select a process. I would say, tada! It shows what are the compatible process materials it is suitable for. Alternatively, if you have a material in mind, let us say we go down to plastics. Let me make this a little bigger. Okay, and if I select plastic, it'll show me what are compatible processes. Is that interesting? Don't have to rely on a manufacturing expert. I have a design. I don't have to go get myself embarrassed in front of somebody who's going to ask me a lot of information about the idea to manufacture this part. I have a tool in a safe environment. Even before I go do the CAD model, before I go talk to my team members, I have the ability to review it. For example, ABS with cold chamber won't work. It says red color means the process and material combinations are not possible. maybe extrusion plastic ABS. If you see a green, means possible. Sometimes I may want to intentionally take something like this. I can say, you see yellows, which means you may be able to manufacture this part, but there's a potential that the some things may be exceeding in terms of possibilities. For example, it is showing you as a warning, hey, if you select cold chamber and aluminum alloy, your volume is 5,000 pieces. It doesn't make business sense to manufacture unless your life volume is 10,000. Gentlemen, even if you're not a manufacturing expert, you have a tool that helps you or guides you in getting feedback like this. Okay, let me do a little dramatic play here. Okay, what I'm going to do is I'm playing a role of this person called Mr. Syed. He and his team have done a good work of doing a DFA review of that existing product, but they've brought it into DFM, but they have no clue that they made an error in giving the average thickness. If you can see my average thickness, you should probably read it out for me.
Sir, it is 12.
12 mm. So let us say this oversight of 12 mm was keyed in as average thickness. I select process and material. Okay, I'll go back and select the same process and material for your information. And I selected cold chamber and I say aluminum alloy. You see what comes up at the bottom, ladies and gentlemen, it's saying, you know what? Last time we showed you an error of 10,000 being unlikely to be economical. Hey, we got another problem. If you have a section thickness which is greater than 11.9 mm, you can't manufacture this part. Imagine if you guys see this error after you come to, you finish your prototyping and you came to the production. Your production guy says, hello boss, you didn't talk to me. Who told you we can make 12 mm? Our machine cannot cast this. You know how much of money and time is spent? Companies spend millions of dollars on the table going through gut feel design or experience-based feedback, and they come at a later stage in the product design process where all efforts is actually sort of lost, or the reverse engineering or re-engineering costs a lot of time and of course a lot of money, right? So this is what the tool is able to throw out to you. This is one information. Second bit of information I'd like to tell you at this point is, DFM is not pure science. Let me repeat, it's not pure science. It is a set of guidelines that have been documented as best practices with industry inputs, academic research done over the last 30-40 years. So while 11.9 mm and 12 mm is not so far away, maybe my manager in production will say, Saidji, don't worry, 12 mm, no, we will manage and get this done if this is important for you. So with that role, I'm going to go back and say, let's go continue and evaluate for 12 mm. Okay? Do you agree what I'm saying? Am I too fast?
Yes, sir. Yes, sir.
Wonderful. So with this 11.3 mm unlikely situation, I still go ahead just for the sake of this presentation and say, okay. Gentlemen, what happened is in about 1 minute, we have quickly created a process chart on for aluminum. We have data specific to our aluminum process. Since I selected the die casting process, it automatically brings up what are the subsequent operations required for die casting, and quickly gives me a review of my cost. Okay, there are other elements also on the right hand side, which is exhibited here. Anishji, I'm so sorry. I would request you to keep yourself on mute. I'm getting, thank you so much. So while I do this first level input, I want to quickly jump and show to you in the DFA, simultaneously this cost. Let me minimize this and show you. So if I'm a design guy sitting somewhere else, okay, whatever cost I'm generating in DFM can come simultaneously into DFA. That's why many of our customers who are either OEMs working with multiple partners geographically, or MNC companies or engineering service companies, they're working in the daytime in America, and by night they have data which is snapped on for them on all their design intents. This is what the strength of the collaborative effort of manufacturing using both these tools. So let me minimize this, and I have some questions now, so that I can take a little short break while I have something to sip. Okay. This is to understand from the audience, and probably Anishji, you can shoot out some of the answers that you see there. Now, my question to the audience is this. Let us say I have a vendor and he says, you know what, aapne to bata diya Syed and company that automatic mein karne se your price is going to be this, but I have only a manual setup. If I select manual, my question is a very simple question. What do you think will happen to this cost? will it go high or will it go low? Will it go up or down? Can you please collate and tell me what is your feedback on this? I know you don't know this product inside out, this component, but just you make a guess. If I select this casting process to be manual, what do you think will happen? High or low? Anish, you just have a look at it
High,
and
sir.
say maybe.
Very high, sir.
No, are there many people saying high or are many
Yes,
people
sir.
saying low?
Yes, yes, sir.
Many people are saying high. Yeah, if you look at the data that we saw just before the screen, it says, hey, if you make 10,000, it's unlikely to be economical. It also told us, right? But that's what I want to tell to those people who are probably experts at manufacturing, who are sitting in this audience today, people from the industry with extensive background. What I want to tell is what applies to one type of a design need not necessarily apply to another. So here's the flash news, ladies and gentlemen. Not only does it tell you whether it's high or low, in a minute when I press on this calculate button, can I click on this calculate button?
Yes.
Okay, I'm doing like this big boss show or something like that, I think. So when I press on calculate, what you see, gentlemen, is a breakup of how a manual process will span out for a production like this. It is not going to be high, it's actually going to be low. You know why? It's not because of the thing. If you see actually the process cost is actually higher here. In the manual process, you were right by saying high because you were probably thinking of the process. But because it is a manual process, something else is coming into play, which is bringing down the cost by a few paisa. Understand what I'm saying? So this is the ability that DFM brings rapidly to get a feedback of your design intent. And that's what part costing does. Let me just add another dimension. What if this is your product like a very high finished smooth component, which requires a very high tolerance? What do you think will happen to the cost? High or low is one question. Second question is, where do you think the cost will go, high or low? Please just make guesses. Feel free to make guesses. I know you don't know these answers.
Sir, high.
Okay, I'm going to press on this calculate button and you will see it is going to be high, of course, because the tooling required to create the negative shape of this part that has to be casted is the one that contributes to the time. If you see the difference in the material setup, process, rejection up on the chart, they do not change. So you can get this cause and effect responses very quickly with this tool. Okay, now in the essence of time, I think we started 15 minutes late. I'm hoping that I can continue for another 15 minutes. Is that okay, Dr. Ajit?
No issue, sir. You may continue, please.
Okay. So while the product brings up these processes, let me just put another angle with respect to a vendor for the people who are from the industry in this audience today. You know, it is the software is saying the ideal machine to make this part is sufficiently a 200-ton cold chamber die casting process. And what I've clicked here is the list of the die casting machines that are available in our database. As you can see, the first machine is marked as 100, is showing as yellow, which means that the clamping force required to manufacture this part may not be suitable with the 100-ton machine. What our software actually intuitively does is it goes and selects the most economical machine on which jobs should be done. It goes and selects and recommends the most effective combination of elements that can help you to get the lowest cost at the first go. Okay, how interesting is that? But now I'm going to play a different role for those of us who are from the industry. Let us say we are talking to a vendor and he says, sir, you have done a casting with this ideal estimation. That is, I understand. But you know what? The smallest machine I have in my factory is a 900-ton machine. So many of our customers use this tool to have a realistic vendor cost estimations. So I will say, okay, check, let us use the 900-ton machines database values and run this analysis. Okay, what happens? You see the cost of running the 900-ton machine, the process cost of that expensive equipment comes up here. So because of which the cost has gone up, right? So if I'm a part of a procurement process in a company, I will say, look, vendor G, ideally my team says 13.95 rupees is good to manufacture this. You are saying 14 rupees is 72 paisa. I am not going to give you that extra 85 paisa or something because you are inefficient with your machine. Either you go and offer this to me, or you go invest in a machine like this, or let me go find another vendor to do this who can make this at this lower cost. All of this can happen in an unbiased manner. Okay, you have scientific feedback or mathematical correlation of your design intent. Interesting. So let me just go and add a couple of elements. I showed you what was a primary process called die casting, but a product like this cannot be just finished with die cast or the first primary process. You may want to have subsequent, secondary, and tertiary operations. So let me go and add a machine tool. So this is the list of machines that you can probably add as a part of our operation after a die casting operation. Many of the commonly used machines in the world are available as a part of our database. Okay. Now you may say, sir, your machine only has what, 7 types of machines? 1, 2, 3, 4, 5, 6, 7, 8 types of machines. Well, ladies and gentlemen, that is not the case. Let me go quickly and show you that we have 3 different libraries. We have a library of operations, materials, and machines. Just in the interest of the context of this part of the session, let me open the machines library. Okay, this is my machine library. All right, and it's very exhaustive. It has got a comprehensive database of machines from different commodities and different actual company, models and makes and manufacturers. Then the question is, hey, why is only these machines coming up? That's what the software beautifully does. What it does is, depending on the process that you have selected, whatever is a possible set of equipment that you can use for subsequent secondary operations, only it will bring up for you to do. Thereby, it prevents any user error. Okay, that's another interesting feature of the tool. So let me just go arbitrarily pick a horizontally machining center and insert it. Okay, so whatever is the operation characteristic of that machine in terms of cost to run it, the cost to in terms of power, the spindle speed. Please note that the spindle speed here is 8,000 RPM. Okay, and you can go and set up other things like what is going to be the cost to set up and unload and load parts or in this machine to do the operations. What type of holding devices you can use. All of this has a bearing on how the cost can plan out. You see, you get a rapid feedback of your design intent. Let me just do one operation here, gentlemen. Let me go and add an operation of drilling 3 holes. Why am I going to drill 3 holes? Because if you remember, this part has 3 holes in the top. So just for the sake of it, I'm going to drill 3 holes. Okay. Let us say that the dimension of the hole is 15. Can somebody tell me what is the length of the hole? If you're watching my input, somebody can tell.
Sir, it's 0. Right now it's 0.
Right now it's 0. Yes, of course. What should be the value I should input there?
Sir, 20. You may keep it 20. If it is related to the part which we are going to manufacture, it has to be same as the thickness. At least.
Yes. So what is my thickness? So what is my thickness?
If the thickness is 12, we may go by 18 millimeters.
Correct. It is no. So the thickness of this part was 12, and I'm going to give 12 as the length of the hole to be drilled. Thank you so much for that, Anish. And we have 3 holes to be drilled simultaneously and 1 hole at a time. So when I key this information and press calculate, gentlemen, automatically the software brings up these attributes. That is the machine data, the machine limitations, and how much of cycle time to machine those holes, and what will be the volume of material removed. All of this is estimated as a part of the exercise. Okay. Now, I'll just show you something interesting. Again, I'll play a role of a vendor. If I was a vendor and a procurement head was looking at this, he will say, you know what? This machining can be done with a machine that has got 1,300 RPM. Why are you selecting such an expensive equipment which has 8,000 RPM to do this job? You see, this kind of estimates can come out to this tool. Now, talking about drill, we gave 2 bits of data and we got this information about 3 information which I can edit and about 4, 5 information that is generated from the tool. Can I show you the library of operations that we have?
Yes, sir. Please.
Okay, here is the library of operations, and these are all the secondary and tertiary operations that one can do as a part of manufacturing a part. So let me go to that selection that I made of drilling a hole. Okay, remember This is the drill hole operation. This is from the library. What was the data it asked us? It asked us, give me the diameter, give me the length, right? But if you see, and if I edit the formula that drives a single drill hole or a drill hole operation, ladies and gentlemen, this, what you see here, is the standardized set of equations and algorithms that drive single drill hole. Okay, let me just move this middle line up. This below is the variables list. You can see the variable list count on the left hand side, 1, 2, 3, 4. There are about 53 variables that drive a single drill hole. Then, sir, why is it not all of them showed? Well, the software is so designed, again, that allows you to focus on your design and not on all the background calculations. So that's why those that the user can edit are being kept in a tick box state, and it is shown to the user are allowed here. Those that are not to be shown are shown sometimes based on the calculation, and many of them are, as you can see, never shown. Now, if you are interested, you want to do some research, you can use this calculation capability. Okay, you can cut paste this out on a notebook and do an entirely different set of review or further research or something like that. So this is also available through the. I hope you appreciate this part of the operations tab.
Yes, sir.
So this is what the I showed you two libraries, that is operations and machines. I'll come back to materials library, that is also part of our system. So I showed you a primary operation. I didn't. What our tool allows you to do is all the activity of converting your raw material, right from the input of the raw material to completely finishing the part and shipping out of the factory. So if you want, I can do subsequent operations like I can do, say, inspection. I can do measurement. Okay, I can do treatment. I can do painting, packing. All of this is a part of the database. In the interest of time, I'm just picking this up. And all of this can become a part of your overall cost structure. So let me just rename this, and I promised you that I'm going to do it in to evaluate this particular cover design in 3 different commodities. I've already done for aluminum and casting. Do I have the permission from you to go and do it in sheet metal and plastic?
Yes, sir.
So let me make a copy of this and paste it. I'll rename this as cover in sheet metal. Yeah, I want to show different attributes as I keep doing this of this tooling capability. So I'll select, given all these things being the same, I'm making a copy of this and I'm going to select and change to a new process and material. Okay, this was our previous selection, cold chamber and aluminum. Now let me go select a different material altogether and also a different, say, process. Okay, intentionally I'm selecting yellow colors just for the sake of talking about a few things. Can you see the limitations it is showing at the bottom? It is saying, hey, if you've selected a process in which the material thickness, if it is greater than 7 mm, may not be practical. I'm saying, never mind. Tomorrow when I go to office, I'll sit with the experts and discuss this. But right now, I want to know what if it is this combination of process and selection for material. And it's saying, can I switch the data from the old to the new? I say, okay. Can you see that warning? It is saying, you know what, Syed, you selected a process and we don't have a machine in our library that can handle 7 mm thickness. Okay, I'll take this note also and I'll say, okay. Even in spite of this error, the tool goes and takes the largest machine in our database and creates this first level estimate. So as I said earlier, this is not pure science. You can see when I look at the laser, the machine that we have for sheet metal, all of them, it is saying it is in yellow. It means all of them are not capable of doing the stamping. But since I said I still cost, it goes and gets the cost based on the most biggest machine that is available, so that I have some reference of this selection that I have made. So this was our previous estimate for casting. This is our new estimate for sheet metal. And of course, the sheet metal questionnaire is different compared to the die casting questionnaire. So each module, each commodity has different types of data that it is generated, which is allowed for you to sort of key in. Now you may say, sir, everything should I know? Well, whatever you know, you key in and you get estimates. If you don't know, get somebody who knows it. But the point is that somebody who knows it has good amount of data on his plate to go around and make changes and give the right inputs rather than waiting for each one of them one at a time. That is the beauty of the tool. So I'm going to take a minute to change the sheet metal data now to plastic. So with this data of the part geometry, the same thing. I am selecting ABS plastic. It's a good engineering plastic. I like it. And I will select, say, injection mold. So here again, it's showing a warning. It says, if you have a section thickness greater than 6.3, unlikely to be practical. If you select production volume less than 10,000, unlikely to be economical. I'll say, nevertheless, I want to do an apples to apples comparison. I'm going to say yes. So in about 10-15 minutes, gentlemen, we had the idea of a part, and we took them through a journey of 3 different commodities, lots of numbers. So let me make it much more easy for you. Let me go and look at the cost totals on a single dashboard. So that's the breakup of manufacturing that cover in die-cast sheet metal plastic. It'll cost you 17, 8, and 17 rupees for 5,000 volume. Okay, and if you move on the graph, each graph will represent how much percentile it is contributing to the fabrication of the part. And the setup is shown in terms of material setup process on the X and Y axis as cost. If you don't like it, you can use a stack bar graph. So if I'm making one prototype, I see tooling cost blue color is 63% in casting. It is 63%, 48% in 44% in plastic. There is no tooling in sheet metal. So I can tell my boss, you know what, if you're going to make one prototype, why don't we select maybe sheet metal? And discussions like this can happen. You can look at this feedback in terms of a pie chart. And if there are anybody from the industry today, I'd like you to show you that you have this beautiful graph called the cost versus life volume graph. This is a logarithmic graph. Okay, so I can use the selection ruler. Okay, so let me see, I have a hypothetical situation wherein I want to check what is going to be this intersection of the red and the blue line. Red line represents cover made by die cast, and the blue line represents cover made by sheet metal. I'll say right click, and here let us say if I'm a vendor and my OEM is saying, oh, I don't like sheet metal, it's very inconsistent, I want die cast. Boss says make an aluminium. I'll say, Sabji, 5,000 doesn't work. If you can give me 25,000 pieces, I will match making these covers in casting instead of sheet metal because I can amortize my overheads at these volumes. Make sense? And there's one interesting feature before I move on and close this session, gentlemen, for questions. A feature called Cost Reduction Guide. This is a tool manufacturing experts could probably use as a part of their activity to explain to designers what attributes of their product is contributing how much to the overall cost of manufacturing the part. So many a times design people are devils for manufacturing people. These people talk a different language, design, ergonomics, human factor engineering. The manufacturing person talks about GD&T, die, mold, cavity, insert, tolerance. So there's no bridge. So this tool, giving a feedback breakdown on based on cost, allows them to have a conversation where this can flow seamlessly from one to another. So with that said, this was a quick overview of the 2 modules of the tool. Let me continue back to my presentation, wherein what I was able to do in the last 10-15 minutes was give you a breakup of those parts and find out what it will be like to make in different commodities, different regions. What I did not show you was you can have different geographical data. We can have data for USA, for China, so on and so forth. And you approach this thing for doing part level, product level DFA and part level costing. A product like this is the kind of benefits you can probably sort of realize. Okay, so a few things to sort of help and wind up is the 3 things that you need to know to get started on doing a DFA or DFM is select your scope of doing your product design review very wisely. What I mean by that is engage with your community of whether a team or members are relevant who can help to participate in bringing about this change. 2 pointers for you to know: if you put small and medium efforts, you get small and medium benefits. This is basically revolves around if you only focus on the part, which I showed you as the second part of my demo. If you want to get larger benefits, you should focus on the product. DFA is that candidate that can help you to do it. Okay, that was my first part of the demo. So you may say, sir, give us an example of what and how to approach it to get started. Here's a brief example. It's a very simple mechanism of a hinge in a military box. And please go and review or attack what you think is your low-hanging fruit. In this case, this overhead, this head assembly, which is a 1, 2, 3, 4, 5, 6, 7 part assembly, is a good candidate for this consideration in this product to be reviewed. Normally, people would end up doing the 3D model and go ahead to make prototypes of the product. But here's a tool, DFM and DFMA, that can help you to get your product breakdown of your existing design, of your best proposed final design, find out the elements that can go out to bring about changes in terms of reduction and simplification and so on. And of course, if you're a part of an industry or a company, it is imperative that your company finds value in terms of what will be the cost or profits that they can make. Because without it, it doesn't make business sense to go ahead to investigate something which is already selling well, right? I've taken another example of a case study from some of our academic friends who did this very long time ago. What do you think this is? This is a torch. How does it work? Well, if you connect an electrical supply a component like a battery and connect it to a bulb or an LED, you should get light. So this is a functional component which converts chemical energy to electrical, and here's a component that converts electrical to light. But why achieve that through 17 parts? So this is a bunch of college grads who have done this, keeping these components as standard, which is the battery which is available off the shelf and the bulb, which is also a commodity that you can buy. They've rejigged the whole of this assembly from a 17-part design to a 6-part component. Again, when you make out and go out for making new designs, there is one thing which you should be aware of is some things are super systems. For example, you may say, sir, you told us about part count reduction. Can I convert these 2 batteries as 1 battery? Well, you have to go start a new everyday factory for that. But that's not the intent. It may not be the area of your immediate focus for your company. So you need to set what you call, what I went in my first slide previously, amongst the 3 things. Set your goal that can be achieved with the capabilities, network, money, time that you have as a part of your project. Another example of a little more complex thing done by a student, something as complex as an aeronautical challenge. And even a tool, like this is a burring tool, which is used for stamping sheet metal part of a motorcycle tank. There's a student project again who published it in an international journal. So last few slides before I wind up in 3 minutes, I will. Question is, when do we get started, sir? It's never too early, never too late. And if you're a part of a company, this applies to you. Educate and involve the upper management and start right away. So some of the tips I'd like to offer for those who are in the engineering service business, especially if you're doing reverse engineering or any type of black box review. If required, do a teardown analysis. If unfamiliar, use people who can contribute. Analyze every suggestion and visualize the consequence. Many times as designers or people with engineering knowledge, when somebody makes a recommendation, you say, that will never happen. Oh, this physics does not apply, and so on and so forth. Please capture as much as design intent, because you have a tool that can help you to give you a design review. Like the motor example I did. Can I do a snap fit? If I talk to actual motor supply, he'll say, sir, what are you talking? Snap fit, I've never done in my life. But I do a what if scenario to find out what will be the benefit of something. When I see value, then I go ahead and see how I can engineer it. That's what I'm trying to profess. That's what most of the Fortune 1000 companies do in bringing about more cost-effective products. Now, if you're a part of a company, gentlemen, or if you're part of a project team, who does what? Well, those who are managing should provide for the team. They should provide time for the team to do this. They should provide tools along with the time for the team to go and investigate, because that is imperative. You can't run your priority projects and also do a stepmotherly treatment to doing a project design review with DFA. Second thing is, when teams engage, you must allow for grouping in, washing out. You may get an idea when you're coming in bus to your college, or while riding somewhere, or getting in your sleep. Please capture it right away and see if you can create unbiased variants of your design intents. Definitely, you are going to do a comparison and deliberation around those comparison of capabilities. So with that, I will probably end my presentation There are some videos that we could probably share to the audience apart from whatever you've done today, and you could probably write to us. I think with that I will stop. If you don't mind, I'll just take a minute to talk about what else we do as a part of our work in about 3 slides. As a company, ladies and gentlemen, I do 2-3 things very passionately. I have a team that does that too. We are into an area where we build customized lithium-ion batteries for new applications as a part of our enterprise. So we are a DSI recognized R&D house for the last 8 years, and we've been around for the last 19 years in the business of doing design development around lithium. Of course, today's session, which is DFMA, very dear to me. We are in the business of doing product costing services around this tool, and these are some of the services that we do very effectively. And third and lastly, this is my own startup in the electric mobility space, where we are building an electric tractor. I'm not sure if this will make interesting to anybody because I saw SAE there, so I thought it'll interest you. That's my electric tractor in action about 4 months ago. That's a 21 HP equivalent electric tractor that you're seeing running around. And just to let you know, last 2 weeks we've been testing it in the farm and in an airport. Once evident, we will probably be able to put that in public domain. And with that, I will stop. Thank you so much for your time and attention.
Thank you, sir. It was very informative session. Now we'll go to the question answer session. Few of the participants they have asked.
Shall I
some
stop
questions.
presenting?
Sure, sir.
No, sir. Please keep your this screen.
Keep your video on.
Keep this.
They can see me, right?
Yeah. Yes.
Only if I stop, they can see me, or they can see me without it also.
I can see you, sir.
You can see the YouTube.
I can see both, sir.
Okay, I mean, if my screen is visible and I'm visible, then I'm good.
Sir, there are a few questions.
Yes,
I'll start with the first one. And it says that as in the process, we are going to reduce number of parts which are to be assembled to make the product, right? So, would there be any effect in terms of strength of the part by reducing the number of components?
Anish, I did not get the second part of your question.
Sir, in the process of this particular DFMA, we are going to reduce number of parts, right?
Right.
So will there be any adverse effect or a negative effect in terms of product's performance when you'll be assembling the product with lesser number of parts?
Okay, this question is from whom?
The question is from Pratik Mahadat.
No, is that a student or an industry person?
He's a student, sir.
Good. Thank you so much, Pratik. Very well articulated. It has been proven from hundreds of industrial case studies that for the given function, if you have 2 products, one product has more number of parts to serve that function. And if there's another product which has lesser number of parts to save the same function, the product which has a lesser number of parts, please hear me clearly, has a higher mean time before failure than a product that has more number of parts. I hope that answers your question.
Well said, sir. So the second question is that do we have an access in terms of we can modify the library of this particular software in terms of materials or machines or processes?
Our customers are always doing that. This is a black box. So you get this tool which has the database of best practices documented as a part of the system. You will deploy it and localize it for the way you do business and how you manufacture products, which will also include what costs you buy, what types of materials you work with, what type of new machines you have. Yes, the library is fully customizable by the users.
Okay. And sir, the third question is from us. Being an academician, I would always like to know that do you have an academic version of this particular software?
So
which you can
here's
offer
the good news.
Institutes?
Yeah. Yes. So here's the good news for you. At the academic, we don't differentiate as a difference between academic institutions in terms of the software that we offer to what we do as commercially. Only difference is that the academic licenses come at a deeply discounted rates, and they come for certain shorter durations. But the version is a full-fledged version because the software comes from 2 academicians from the University of Rhode Island. So yes, we have academic licenses that are available, Anish.
Thank you, sir. We'll definitely look into that particular direction. Now I would like I would propose Dr. Ajit James to go for vote of thanks. Please, sir.
So good morning to all of you. It was indeed a great session by Mr. Syed. In fact, my acquaintance with Mr. Syed started when I attended a one full week FDP conducted by Mechanical Department of IIT Kanpur in the month of February. There, Mr. Syed had a almost half-day demonstration of this software and discussion of these concepts. In fact, being an academician, particularly working in the domain of design, manufacturing, maintenance, etc., currently, as a teacher, I would say our particularly academic awareness related with this concept of design for manufacturing is limited to maybe 10 to 15 pages of design for manufacturing concept that also mentioned in the book of fundamentals of machine design by Professor V.B. Bhandari. So that is again included as a theory part in some of the chapters of design. Maybe it is taught in the 5th semester or in the 6th or 7th semesters. Apart from that, there is no exposure to particularly BE students in this domain. But I had some experience working with the industry, and once I did my post-graduation and then while doing PhD, these are some of the current topics in research as well, and very much needed for the industry, particularly when you are looking for lean manufacturing. So now this subject has a very big scope in the future. Particularly, this is there is a dedicated software, and very particularly during my interaction with with Mr. Syed, I came to know about that particular book by Boothroyd. So I got that book from the library of IIT Kanpur, and I have a copy of that with me right now. It's a very informative. In fact, it is the full life experience of Mr. Boothroyd and Dewhurst is bundled in that book, and the same is done in this software. So I recommend that BE students, master students, and even PhD candidates, if they have an experience in this software, definitely you can find very good opportunities in the academics as well as in the industry. And as far as Mr. Syed is concerned, it's usual way of giving the lecture in a very what we call informative and interactive way. And we are very thankful to him for sharing his valuable time. They are also pretty busy with their regular consultancy work and all. But in that situations also, he spared time with us for sharing his knowledge. And I am sorry to the Mr. Syed and all our participants that we had some technical glitches in the beginning. Though we have done extensive trials yesterday, but some unexpected glitches came today. I'm sorry for that, but we could manage. And today, most of you people were able to see that. I am thankful to all of them. And we have just uploaded the Google Form link in the YouTube chat box. So many people are saying that it is not visible. I don't know why it is.
Sir, probably it's just because the YouTube live is going 15 seconds lag. He'll be getting it.
Yeah. Otherwise, I have already showed the link already. One request is coming. The link is not visible like that. It is coming. I'm again reposting it. Now I hope it is visible to all of the participants.
Sir, no issue. We'll be mailing for feedback links to all the participants who have attended that. The same way they have got the link for joining this particular YouTube video.
Yeah.
Fine.
We will be sending it to the. We have your email ID, and
Sir, on behalf of ADIT family and CVM family, we are thankful to you, Syed sir, for sparing a valuable time and giving us a very detailed introduction about the DFMA software as well as your expertise in the field of DFM. As Narendra Modi sir had given us the task to make things in India and use or to go for locally made products. This particular concept is going to help all the say manufacturers of different commodity items for sure, and definitely this is going to rise up the manufacturing sector in particularly in context of the reduction of cost, or rather say controlling the cost of producing the product in the market. Thank you very much, sir. So on behalf of
sir,
ADIT,
Ainesh, just a second. What I will do is I can post this on the screen. This link on the screen.
I
Just
can
a
also
second,
do that.
Okay, then you do one thing. You do one thing. You keep this on the screen, and people, those who are watching in the YouTube, at least they can take the screenshot and then do that also. I think that also will work.
Yes, sir. For that, Syed sir will have to stop his presentation. Please.
Absolutely. So I will stop presenting, and but at the same time, I mean, are we closing now? If so, I just have one parting remark. In continuation of what Ainesh just said, as a enterprise, we have our mission, which is to see India go up on the World Innovation Index. So one way we want to do it, which is with our strength of creating this awareness to the design community of the availability of a tool like this to be able to do an unbiased review of their design capabilities or design intent. So of course our contact details are available for anybody who wants to write to us, and we'll be more than glad to take it up to getting more serious engagements in terms of doing online training or even consultancy and so on. Thank you so much for the opportunity one more time to ADPIT in words, and Dr. Ajit in particular, and new team members Ainesh, Vishal, and the rest of the crew.
Thank you, sir.
Is there anything to continue, Ainesh, or is it good to sign off?
Sir, you may sign it off.
You can sign off.
Okay. Thank you so much for everything, gentlemen. Pleasure.